Hello and welcome. I am Dr. Geraldina Fernandez, Associate Professor, Department of Mathematics and Statistics, the Bhopal School of Social Sciences. Dear students, in this module, we are going to discuss about linear differential equations. And the following topics will be covered during the lecture. In this lecture, we are going to discuss about the definition of differential equations, the definition of linear differential equations, and the standard form of linear differential equation, followed by the working rule to solve linear differential equations, and at the end, with the use of this rule, we are going to solve few questions. Now, before moving on to the definition of differential equations, first let us understand the definition of variables and equations. So, variables are the quantities which can be changed or whose value is not fixed according to the mathematical operation that is performed. So, basically variables are those quantities whose value is not fixed. That means it keeps changing with time. And now there are two types of variables. The first one is the dependent variable and the second one is the independent variable. Now, dependent variable is categorized as the variable whose quality depends on the estimation of another variable in its condition. That means, in simple terms, dependent variables are those variables whose value depends upon the value of another variable. And independent variables describes a variable whose values are independent of the changes. So, here you must have studied that y is a function of x. Say for example, to understand this we can take y is equal to x square. Now here we have two variables x and y. Now here if you put the value of x as 1, we will get the value of y as 1. If you put the value of x as 2, the value of y will be 4, so on and so forth. So that means if randomly we select the values of x, the value of y depends upon the value of x. So in this context, y is the dependent variable whereas x is the independent variable. So here the value of y is dependent upon the value of x. So now you have understood the meaning of variable. Now moving on to the next definition, that is equation. So equation describes the relation between the dependent variable and the independent variable, and an equal sign is required in every equation. That means it is a mathematical expression which consists of constants, variables, operator as well as a sign of equality. So for example, the expression x plus y is equals to 2 is an example of equation. Here x and y are the variables, plus is the operator, 2 is a constant, and we have a sign of equality. So those mathematical expressions which have the sign of equality along with the variables, the constants and the operator, those expressions are called as equations. Now we have another example of an equation, y is equal to 7x plus 8. So here you can see that x and y are the variables, plus is the operator, 7 is the coefficient of x, 8 is a constant, and this expression in totality is an equation. Why? Because it has a sign of equality. Students, by now you have understood the definition of variables and equations. Now moving on to the definition of differential equations. So equations that involve dependent variable and their derivatives with respect to the independent variables are called as the differential equations. Now simply they are not equations, they are differential equations. That means the equation which consists of the dependent variable as well as their derivatives with respect to the independent variable are called as differential equations. So for example, here we have two examples, dy by dx plus 2 is equals to 0. So clearly this is an equation. Now this equation is also called as differential equation. Why? Because here the equation consists of one derivative. It can have one or more than one derivatives, but since this equation, the expression has a sign of equality, along with this it has one derivative. So this equation is called as differential equation. We have another example. d2y by dx square plus dy by dx is equals to e raised to the power x. So this is another example of differential equation. Why? Because this equation involves derivatives. This is the first order derivative, as well as it consists of the second order derivative. It has a sign of equality. So this mathematical expression or this equation can be called as a differential equation. So it is clearly mentioned that the equation should involve dependent variable. Here in both the examples, the dependent variable is y. So it consists of dependent variable and their derivatives. So here we have derivatives, one or more than one it can have. So with respect to the independent variables, here x is the independent variable. So such equations are called as differential equations. Now the next important definition is order and degree of differential equations. So first we will look at the definition of order of differential equation. So the order of differential equation is the highest derivative that appears in the differential equation. That is the highest derivative. So there may be one or more than one derivatives in an equation, but the highest derivative that is appearing in the differential equation, the order will be considered as the order of this differential equation. So here in this first example, d2y by dt square plus dy by dt is equals to 0. So yes, this is a differential equation. Now since the highest order derivative that is appearing in this differential equation is, the order is 2. So therefore the order of this differential equation will also be 2. Next, second example. Second example is dx by dt is equal to x into d cube x by dt cube. So this is, yes, this is a differential equation. Why? Because it consists of the dependent variable as well as its derivative. So this is a differential equation. Now talking about the order, so we will have to check the highest order derivative. So among dx by dt and d cube x by dt cube, among these two derivatives, this one is having the highest order. So therefore the differential equation will have third order. So now moving on to the definition of degree of differential equation. So the degree of differential equation is the power of the highest derivative term. So the degree is the power of the highest derivative term. Let us understand this with the help of one example. Here we consider a differential equation d2y by dt square minus 6 dy by dt plus 7y is equals to 0. So first we will discuss the dependent as well as the independent variable. So in this particular example, the dependent variable is y, the independent variable is t, and the highest derivative that is appearing in this equation is d2y by dt square. Obviously dy by dt is one-time differentiation, and d2y by dt square, that means we have to differentiate it twice. So the order of this derivative is the highest in this particular equation. So the order of differential equation depends upon the highest derivative. So here the highest derivative is 2. So the order of this differential equation will be 2. Now talking about the degree of this differential equation. So for degree we will check the power of the highest derivative. So here the power of the highest derivative is, you can see, that is 1. Here the power is 1. So if the power is 1, then the degree of the differential equation will also be 1. Now let us take another example to discuss the order and degree of differential equation. So here we have a differential equation d2y by dx square minus 6 dy by dx whole square plus 10y is equals to 8. So this is also a differential equation, and the highest order derivative that is appearing in this differential equation is d2y by dx square. This is the highest order derivative that is appearing in this equation. Now, talking about the degree, order is 2, talking about the degree. So, here few may have the doubt that the degree of this equation will be 2. Why? Because dy by dx has the power 2. But you will have to look at the definition very carefully, that is, they are asking you to check the power of the highest derivative. So, the power of the highest derivative in this example is 1. So, the degree of this differential equation will be 1. Even though the degree of dy by dx is 2, but still we will consider the power of d2y by dx square as the order of the derivative is the highest among these two. So, now let us discuss few more examples of differential equations. So, talking about the first one, we have dy by dt plus y is equals to 0. So, yes, this is a differential equation, and the derivative that is appearing is in this differential equation is dy by dt. So, the order of this differential equation will be 1, and the power of this derivative is 1. So, therefore, the degree of the differential equation will be 1. For the second example, we have dx by dt plus x square is equals to 0. So, here this is a differential equation, and this is a non-linear differential equation. Why? Because the degree of the dependent variable as well as the derivative is not 1. Here the degree is 2 and there the degree is 1. So, this is an example of non-linear differential equation. Here, since the degree is 1, so this differential equation can also be called as linear differential equation. So, now let us understand the definition of linear differential equation. So, a differential equation is called linear if there are no multiplications among dependent variables and their derivatives. In other words, all coefficients are functions of independent variable. So, let us understand this with the help of an example. So, a differential equation, so basically it should be a differential equation, that means it can have one or more than one derivatives along with the dependent variable, and those differential equations will be called as linear if there are no multiplications among the dependent variables and their derivatives. So, let us take one example. Here we have d2y by dx square minus 2 dy by dx plus y is equals to 0. So, this is a differential equation. Why? Because here we have dependent variable as y and its derivative. So, this is a differential equation. Now, this differential equation will be called as linear. Why? Because here there are no multiplications among the dependent variables and their derivatives. So, here we have d2y by dx square minus dy by dx, there is no multiplication of another dependent variable. Therefore, this is an example of linear differential equation. We can also say that since the degree of the dependent variable is 1 throughout, along with the derivatives, the degree is 1 throughout. So, therefore, this differential equation will be called as linear differential equation. So, now moving on to the standard form of linear differential equations. Linear differential equation in y is expressed as dy by dx plus py is equals to q. So, this is the linear differential equation in y, because the dependent variable that is used in this differential equation is y. Here p and q are constants or functions of x. Similarly, we have another linear differential equation in x. The first one was in y and the second one is in terms of x. So, it is expressed as dx upon dy plus p1x is equals to q1. So, here p1 and q1 are either constants or functions of y. Here p and q are constants or functions of x, and for the second form, the constants P1 and Q1 are either constants or they are functions of y. So these two are the standard form of linear differential equation. Now the next question is, what is the solution of these differential equations? So solutions are categorized into three. The first one is the general solution, the second one is the particular solution, and the third one is singular solution. So let us understand this one by one. So general solutions are those solutions obtained from integrating the differential equations. The general solution of an ordinary differential equation contains arbitrary constants resulting from integrating times. Whereas particular solutions, if we talk about particular solutions, they are those solutions that are obtained by assigning specific values to the arbitrary constants in the general solution. And last but not the least, singular solutions can never be expressed by the general solutions. So only those solutions which can be expressed by general solutions are called as particular solutions, and those solutions which can never be expressed by the general solutions are called as singular solutions. So in the next slide, we are going to discuss about the general solution of linear differential equation. So now we will discuss the formula for general solution of linear differential equation. So the general solution of the differential equation that is given by dy by dx plus py is equal to q is as follows. Y into integrating factor is equal to whole integration of q into integrating factor dx plus c. Here c is the constant of integration, whereas the integrating factor for this differential equation is given by if is equal to e raised to the power integral p dx. So the value of p and q will be obtained from the coefficient of y, p will be obtained from the coefficient of y, and q will be the right hand side of the standard linear differential equation. Now another form of linear differential equation is dx upon dy plus px is equal to q. So the general solution for such type of differential equation is given by x into integrating factor is equal to whole integration of q into integrating factor dy plus c. Here c is the constant of integration, and the value of integrating factor is calculated with the help of the following formula, that is given by e integral p dy. So now we will discuss the working rule to solve linear differential equation. So the following three simple steps are helpful to write the general solution of linear differential equation. So step number 1, simplify and write the given differential equation in the form dy by dx plus py is equals to q, where p and q are either numeric constants or they are functions of x. So first step is you have to simplify and write the given differential equation in the standard form. So here it can be dx upon dy plus p1x is equals to q1. So the another form is this. Now the second step says that you have to find the integrating factor of the differential equation, which is given by if is equal to e integral p dx. Now in case of this form of differential equation, the integrating factor will be e integral p dy, p1 dy. And the last step is, now we write the solution, that is the general solution of linear differential equation as follows, as we have already discussed, that is y into integrating factor is equal to whole integration q into integrating factor dx plus c. But this formula is for the differential equation dy by dx plus py is equal to q. Talking about the general solution of this form of differential equation, it is given by x into integrating factor whole integration q into integrating factor dy plus c. So now dear students, we will solve some practical questions in the next module.